Module 1, Lesson 14, from ratio tables, equations, and double number line diagrams to plots on the coordinate plane. So we've been working with all these different equivalent ratio representations, ways to look at them, and now we're going to put them on the coordinate plane and see what they look like. It's kind of a fun activity. All right, we are definitely going to be writing ratios to represent real life situations, and we've got 3 different ways to look at equivalent ratios, and we're going to be using those. All right, so we're going to use a ratio of A to B, and we're going to turn that into an ordered pair that we can put on a coordinate plane. And the coordinate plane is that grid with the x-axis and the y-axis where you go over and up and you put points on there. So we are going to use ratios and put points on the coordinate plane, and we're going to see what happens. And that's what plot means, put them on the coordinate plane. I can represent ratios in ratio tables, equations, and double number lines. So we're going to use our different strategies for equivalent ratios. All right, so Kelly is traveling by train with her soccer team from Yonkers, New York to Morgantown, West Virginia. And they're going for a soccer tournament. And the distance between Yonkers and Morgantown is 400 miles. So they've got these tables down here, and I see that Yonkers to Morgantown is 400 miles. It says the trip is going to take 8 hours. So I've got 8 hours over here, and I've got 400 miles over here. And we've got the train schedule. So if it's 400 miles from Yonkers to Morgantown, that would mean it's 300 miles to get to Berkeley Springs, and 200 miles to Carlisle, and 100 miles to Allentown. And there's part of me that kind of turns my head on the side here, and I see a tape diagram. If I were to put Yonkers in here, I've got Yonkers to Allentown, Allentown to Carlisle, Carlisle to Berkeley, and Berkeley to Morgantown. And I see that I've got 1, 2, 3, 4 legs of the journey. So I'm noticing that there's separations of 2 hours as we go. And then this other table is just the same trip in reverse. So exercise 1, we're going to create a table to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule. We are going to travel at a constant speed. So the ratio of the amount of time to the distance. And we're measuring time in hours, and distance is being measured in miles. So the ratio of the hours to miles is going to stay the same. So all the ratios on my table are going to be equivalent. So we leave Yonkers, and we travel to Allentown, and that is a distance of 100 miles. And then from Allentown, we travel to Carlisle, which is another 100 miles. So now I've traveled 200 miles. So Yonkers to Carlisle is 200. And we leave Carlisle and travel to Berkeley Springs, and that is another 100 miles. So I've now traveled, well, the team has traveled 300 miles. And then we leave Berkeley Springs and we travel to Morgantown, which is a total of 400 miles. And it says that this complete trip was 8 hours. Now, when I kind of turn my head on the side, I'm seeing something like a tape diagram here. I'm seeing that this total trip is 8 hours, and I see that it's split into 4 parts. And I know the 4 parts are equal because it says our ratio of hours to minutes will stay the same. So 8 hours divided by 4 is going to tell me that each section is 2 hours. So I've traveled 2 hours, now I've traveled 4 hours, now I've traveled 6 hours, and now I've traveled 8 hours. So each one of these blocks is worth 2, but I'm doing a running total here of how many hours. After 2 hours, I've traveled 100 miles. Well, Kelly and the team have traveled 100 miles. After 4 hours, they have traveled 200 miles. After 6 hours, they've traveled 300 miles, and after 8 hours, they've traveled 400 miles. And it says here that I am supposed to extend the table to include the ride home. So they leave Morgantown and they travel for another 2 hours, and they've traveled another 100 miles. Now, should I put 2 hours there? No, because it was another 2 hours. So now they're at 10 hours. And they'll travel from Berkeley to Carlisle, which is another 2 hours, and another 100 miles. And they'll travel another 2 hours and another 100 miles. See if I can get this right here. 700. There we go. And they'll travel another 2 hours and travel another 100 miles. So double checking my work here. Do I have them taking 8 hours to get from Yonkers to Morgantown? So they started traveling, traveled 8 hours, and have traveled 400 miles. Yep. So it said that it takes 8 hours, and it says the trip is 400 miles. And then, checking here, do I have another traveling of 8 hours? 8 to 16. Yep. Do I have another 400 miles? Yep. So I have made sure that I've got the right stuff on my table here. All right. Jump ahead here to the next slide. All right, so hopefully your table looks something like this. And you'll notice that I tried to walk through very carefully how I got my table to look this way. So now that we've got the table, we're going to create a double number line to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule. And then we're going to extend the double number line to include the cumulative time it will take to reach each destination on the ride home. So here I'm going to have the time traveled, and here I'm going to have the distance. Well, when we've traveled no hours, we've traveled 0 miles. And then we were counting the time in increments of 2. So 2 hours, 4 hours, 6, 8, 10, 12, 14, and 16. We were counting by 2s. The miles we were counting by 100. After 2 hours, we had traveled 100 miles. 200, 300, 400, 500, 600, 700, and 800. So now I've taken my table of equivalent ratios and I have transferred it to a double number line. And I've still got my ratios here. 2 hours is equal to 100 miles. 4 hours is 200 miles. 6 hours is 300. 8 is 400. So there's all my ratios lined up together on the double number line. Now, it says to represent the ratio of the distance traveled to the amount of time with an equation. So I've got my double number line, and now I need to use my double number line to come up with my equation. Now I know that I'm working with the ratio of time to distance traveled. I know the time is 2 hours, and I know that the distance traveled is 100 miles. So I need to do some thinking here. What is the actual ratio relationship here? What is the value of this ratio? Well, I know the ratio is 2 to 100. And if I write that in largest possible units, I know that, let's see, put time to distance. So I know that in 1 hour, I'm traveling 50 miles. So I know that time is equal to 1/50th of the distance. Time is 1/50th of the distance. Now I can turn that around, and by the way, this draws off of lesson 13. I know that the distance to time ratio is 100 miles for 2 hours. Writing it in the largest possible units, I know that I've got 50 miles in 1 hour. So I know that the distance is equal to 50 of the time. So I've got a couple of nice equations here that I can work with. Represent the ratio of the distance traveled on the round trip to the amount of time taken. So I want distance to time. I think this is the equation that is showing me distance to time. All right, let's step ahead here and see what they have in store for us. All right, so here is the double number line, and we have already looked at this and explained our way through it. Okay, so using the information from the double number line, how many miles would be traveled in 1 hour? All right, well, let's see here. Double number line. 1 hour goes between 0 and 2. And I know that 1 is exactly halfway. So there's my 1. And if I look carefully, I can now see my tape diagram hidden there in my double number line. So I have taken the 0 to 100 and I have divided it by 2. 100 minus 0, so 100, and I want to divide that by 2, and I'm going to find that each piece is worth 50. So after 1 hour, I can see that I have traveled 50 miles. So my distance to time is 1, 2, distance to time. Got to write those in the right order. 50 to 1, which we just looked at on the last slide. So we would travel 50 in 1 hour. Now how do I know? Well, my tape diagram shows me right here. It shows that each hour is equal to 50. Because 1 is halfway between 0 and 2, and 50 is halfway between 0 and 100. And I've got my equation that we've already looked at, that the distance is equal to 50 times the time. All right, so let's take a look here. So dinner service starts once the train is 250 miles away from Yonkers. Now, hopefully your brain is screaming at you, wait a minute, I don't have 250 on my table. I didn't have 250 on my double number line. So the question is, what is the minimum time players will have to wait before they can have their meal? And this is where we get to play a little bit here. So we know that after 2 hours, we had traveled 100 miles, and we know that after 4 hours, we had traveled 200, and we know that after 6 we'd traveled 300, and we know that after 8 we'd traveled 400, and after 10 we had traveled 600. And here is where we're going to play and put these into ordered pairs. And I know that your table goes farther. Go ahead and extend it. So this is our ratio of A to B, and we are going to write this in ordered pairs of A, B. So 2 is the A, 100 is the B, and we've got 4 and 200, and 6 and 300, and 8 and 400, and 10 and 600, and you need to continue extending yours out there. So now, taking a look at the ordered pairs, we have a coordinate plane here. How would we put this information onto a coordinate plane? And this would be a great time to pause the video and try this out and then compare what you're doing with what I do. Well, I am comparing hours and miles. So on the x-axis here, I'm going to put my hours, And on my y-axis, I'm going to put my miles because I have a comparison going on. And I notice here that I've got lots and lots of teeny tiny little lines, probably smaller than I really need. So I'm going to write my hours a little bit smaller here. Hours. See if maybe even I can change the pen so it writes a little bit smaller for me. Okay. So I'm going to go 1, 2, 3. I'm going to put a 1 there. 2 more, 2, 2 more, 3, 2 more, 4, 2 more, 5, 2 more, 6, 2 more, 7, 2 more, 8, 2 more, 9, and 2 more, 10. So I'm going to spread things out a little bit so that we can actually see it in the video. Now the miles I'm counting up by hundreds. Well, I'm going to do 2 lines is 100, and 2 more lines is 200, and 2 more lines is 300, and 2 more lines is 400, and 2 more lines is 500, and 2 more lines is 600, and 2 more lines is 700, and 2 more lines is 800. And I could go all the way up to the top here. All right, so at 2 hours, I've traveled 100 miles. 2 hours, I'm going to go up 2 lines, and there's my 100 miles. And of course, my pen is just a little bit off. There we go. And I'm going to go, oh, wait a minute, I'm supposed to be on 2 hours. It's kind of good to get these things right. So 2 hours, 100 miles. And 4 hours is 200 miles. 4 hours is 200 miles. So 1, 2, 3, 4. And I go 6 hours. 1, 2, 3, 4, 5, 6 is 300. And 8 hours is 400. 1, 2, 3, 4, 5, 6, 7, 8. And 10 hours is 600. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And now I've got kind of this line that can connect them all. And of course, if my pen were a little bit better calculated, my line would look a little bit better. So now let's see if we can figure out where 250 is. See if I can fix my line so it's just a little bit more useful to me. There we go. That looks a little better. So where is 250 miles? Well, here is 100, here's 200, and I was counting in between, so there's 150, so there's 250, and if I follow 250 over, I can see that it crosses my line right there. I can see that 250 miles is equal to 5 hours. And instead of getting this by using the table of equivalent ratios, instead of using the equation, instead of using the double number line, I actually used a graph this time to look at it. Now, I can double check that using the equation that I came up with. And I figured out that the distance was equal to 50 multiplied by the time. And I found out the time was equal to 1/50th of the distance. Those were the two equations that I came up with using the value. Now I've got the distance and I want the time, so the time is equal to 1/50th of the distance of 250 miles. So the time is equal to 250 divided by 50, which equals 5. So now I've got a graph that shows it to me, and I have used the value of the ratio that I found to help me answer the question. So it's going to be at least 5 hours before they have their meal. All right, so kind of a fun lesson, kind of fun to play with. We're not going to go a whole lot deeper on this today. The basics is you create a table of equivalent ratios, you put it on a graph, and then you can find information using the graph. So why use a graph to represent a ratio? It gives you a visual representation. You can actually see what your relationships are doing. And sometimes that can be a little bit more efficient. It can go a little bit faster. All right, so lesson summary. A ratio table, equation, or double number line can be used to create ordered pairs. So we've got this equation, we've got a ratio table, and we can have a double number line. And we can take the information off of all of those and create ordered pairs. And then we can take those ordered pairs and put them on the coordinate plane and see what our information looks like. And from this, we can actually then start to answer questions, draw some conclusions. All right, so learning targets. Hopefully you are, by now, feeling really comfortable with writing ratios to represent real-life situations. Hopefully you are starting to feel really comfortable with representing ratios. We have tables, we have equations, we have double number lines, and now we have coordinate planes. We're representing equivalent ratios 4 different ways. Mixed into this, we are actually looking at the value of the ratio, which is a big step towards working with unit rate, which is coming soon. So the ICANs for the lesson, hopefully you feel like you can take a ratio, turn it into an ordered pair, and then put it on the coordinate plane. And like I said on the last slide, hopefully you're feeling comfortable with these ways to represent equivalent ratios. So that's Module 1, Lesson 14. If you've got questions, make sure you talk to your teacher. Make sure you complete your problem set.